I hope that you have go through with example 1 and 2 in the previous video, and you have actually tried uh, the example 3 and also example 4 before you go through this video. I hope that you can try out example 3 and 4 first before you look for the answer from this video. Right? So let us start with example 3. In the previous video, we actually learned how to use the common sense and also the possibility space diagram to get the answer for probability. Alright, so for example 3, I would like to leave it for you to decide which is the correct method that you want to use. Is it common sense or is it the possibility space diagram? There's no correct or wrong answer, correct or wrong method, sorry. There are no correct or wrong method. As long as the method is suitable, then you can just use it in the exam, right? So let's have a look for example 3. They are having two fair dice with 12 sided, and all the sides are marked from number 1 until 12. And also the numbers on the side which land face down are noted. So the event Q and R are defined as follows. So Q is the product of the two numbers is 24, and R is the event of both the number are greater than 8. Alright, so they actually want you to find the probability of Q and also the probability of R. Please take note that if, let's say for this example, if I want to draw a possibility space diagram, it will be very time consuming, as one set of outcome, I'm having 12 numbers here, and I'm having two sets of 12 numbers outcome. Therefore, for these two parts, if possible, I will just use the common sense to try and figure out the answer. Of course, you can use a possibility space diagram if you are confused or you're not so sure whether the answer is correct or wrong. Alright, okay, so for event Q, since they say that the product of the two numbers is 24, so I would like to check from the smallest number first. So let's say I'm having the smallest number 1. There's no 1 cannot pair up with any number to get a 24. Alright, so 2, when they multiply with 12, then they can get a 24. And the same thing happens for 12 and 2. So you need to list out the outcome one by one. The next number is 3. So 3 multiplied with 8, you get 24. And the same thing happens for 8 multiplied with 3. What else do you have? What else? 4 and 6, and also 6 and 4. So if you continue to check with all the possible outcomes, there's no more numbers that the product of the two numbers will get a 24. So these are all the possible outcome for my event Q. So if you calculate the number element in the event Q, you realize that it is actually 6. 1, 2, 3, 4, 5, 6, right? Okay, so there are 6. To calculate the probability of Q, it will be actually equals to 6. And how many outcome we have in the sample space? Alright, so for set 1, outcome is 12. Set 2 outcome is 12 also. So imagine you have a possibility space diagram. The total number of outcome for the sample space is actually 144. Okay, you can verify it by drawing a possibility space diagram if you want. And 6 over 144, you will get 1 over 24. This will be your final answer. Alright, and then for part number 2, they want you to calculate the probability of R. Alright, so to get the probability of R, of course, if you want, you can list all the possible outcome. If you don't want, then you can just use the common sense to try and figure out the answer. Alright, so if let's say I don't want to show you a full possibility space diagram, I just want to show you all the let's say I don't want to list out all the possible outcome for 1 until 8. I skip all the number there. So I'm having 9, 10, 11, and 12. Alright, so that means both number greater than 8 will start from 99, 910, 911, 912, and so on. So if you draw a very simple possibility space diagram, you will see that there are 16 cells with both number which is greater than 8. Therefore, you are having 16 here over the total number of sample space, which is 144, and that's why you get 1/9. So this is how we actually try to solve example 3. Okay, next we go to example 4. Okay, so for example 4, actually, before you answer it, you need to know what do we have in a set of playing cards. So for a set of playing cards, we are having 52 cards in total. Alright, so I just roughly tell you what we have lah. Okay, so for any set of playing cards, we are having actually 13 cards, 13 different parts. So we're having A, which is a 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10, then Jack, Queen, and King. Alright, so please take note that the JQK, we call them as picture card. Whereas all the other cards are actually numbers are from A which is a 1, right? So A is a 1 until 10. So only JQK we call them as a picture card. Alright, so for every single card here, for every single set of cards here, we are having different suits. Okay, so the first one is this one with this pattern. So this pattern we call it as a spade. Right? Then please take note that for the spade suit, it is actually black color. Alright, then the second type of the suit is a red color, called as heart. Right, and the third type is club, and the pattern look like this. So the club card is actually again is a black suit, black color suit, club, and after that we are having diamond. So the diamond suit is actually red suit. Okay, so for spade, you are having a set with 13 cards. For heart suit, you are also having a set of 13 cards and so on. That's why the total of the card of one set of playing card is 52, which is 13 times 4. Right? Then let us start with the first question here. They want you to find the probability that the card is the 4 of spades. So the 4 of spades means this one. There's only one 4 of spades from all the 52 playing cards. So for this summary that I draw here, this figure is actually a very simple possibility space diagram that you can refer. Alright, so when they are asking for the 4 of spades, means this one. There's only one 4 of spades in a set of cards. Therefore, the probability is actually equals to 1 over the total of the sample space, which is 52. So we are having 1 over 52. Proceed to part number B. So for part number B, there's a typo here. It should be a spades. Alright, so the 4 of spades or any diamond. Right, so if let's say when you select a card that belongs to 4 of spades, which is this one, or any diamond. So any diamond means all the cards should be included in your calculation to get the probability. Alright, so the total outcome for the event is 13 plus 1, which is 14. and divided it by the total number of the sample space, which is 52, and eventually you will get 7 over 26. Next, let us proceed to part number 2. So if you go through with part number 2, they already tell you that the first card deal is placed face up on the table. It is 3 of diamond. That means there's one card being selected before you get the second card. Alright, so the third of diamond is no longer available anymore and no longer in the playing cards anymore. So now your playing cards only left 51 in total. They are asking for the probability that the second card is from a red suit. Alright, so since you already don't have the diamond 3 at first step, okay, so now please count how many red suit cards are still available here. So you're having 13 cards from the 13 cards from the heart suit, and also you still have 12 cards from the diamond suit. That means to calculate the probability, the total card is 25 over the sample space outcome is 51 because the 3 of diamonds is already no longer available. Right, so that's why the total sample space becomes 51 and the answer is 25 over 51. So do you get the answer correctly?